Hello everyone, myself Shweta Kulkarni, working as Assistant Professor at Sri Venkateswara College of Engineering, Bangalore. Welcome to video lecture series on computer organization and ARM microcontroller. This is the introductory video where I'll be talking about the course contents and course outcomes. This subject, computer organization and ARM microcontroller, is introduced by the university for the third year students of Electronics and Communication Engineering. Before learning the concepts of computer organization, you should have a basic knowledge of functional units of computer system. This video lecture series will provide you in-depth knowledge of internal working, structuring and implementation of computer system and also provide a knowledge on ARM-based microcontroller. Let me tell you one basic point. You can see two things in this particular topic. One is computer organization and the second is ARM microcontroller. There is a difference between these two. You can understand, you can define computer organization is how the operational parts of computer system are linked together, while ARM microcontroller is a 32-bit RISC processor which is used in an embedded systems. Or in a simple way, you can state computer organization explains how computer works and ARM microcontroller explains how it is used in embedded applications. This is the basic difference between the computer organization and ARM microcontroller. Let us discuss about the course content on which you will be observing the upcoming videos. What contents I am going to cover in this lecture series. Let us begin. First is the basic structure of computers, which consist of basic operational concepts. What are the different bus structures? Performance of the processor clock, basic performance equation, clock rate, performance measurement. The second part in module 1 is input-output organization. How do you access I/O devices? What do you mean by interrupts? How is the interrupt hardware designed? What is direct memory access buses? What are the different types of interface circuits? Standard I/O interfaces like PCI bus, SCSI bus, USB. Memory locations and addresses. Byte addressability, Big Endian and Little Endian assignments, accessing numbers, characters and character strings, different types of memory operations, instructions and instruction sequencing, what are register transfer notation, assembly language notation, basic instruction types, instruction execution and straight line sequencing, branching, condition codes, generating memory addresses, what are the different addressing modes, basic input-output organizations, what do you mean by stacks and queues, subroutines, and the additional instructions. The course outcome of this module is to explain the basic organization of a computer system. Next, going to the module 2, we'll be discussing about the memory system, the basic concepts of memory, what are the different types of memories, or how do you design a semiconductor RAM memories, different types of memories like read-only memories, cache memories, how do you decide the parameters for the memories like speed, size and cost, different mapping functions for the cache memories like mapping functions, replacement algorithms and performance considerations. The second part of module 2 is basic processing unit, where you will be discussing on some fundamental concepts, the execution of complete instruction, what is multiple bus organization, what are hardwired control and microprogrammed control, and also the basic concepts of pipelining. The course outcome of Module 2 is to demonstrate the functioning of different subsystems such as processor, input, output, and memory. Coming to Module 3 is based on the ARM embedded systems. The first two modules deals with the computer organization. Module 3, 4 and 5 are based on ARM embedded system. In ARM embedded system, the introduction, what is RISC design philosophy? What do you mean by ARM design philosophy? How the embedded system hardware is designed? What are the different bus protocols that are used for the embedded system hardware, like AMBA bus protocol? What is the technology? How do you design a memory, peripherals, embedded system software, which includes a stack of steps like initialization, operating system, and applications. And also it consists of the ARM processor fundamentals, ARM core data flow model, registers, what are the current program status registers, pipeline, exceptions, interrupts for the ARM embedded system and vector table, and also the core extensions. The course outcome for Module 3 is to describe the architectural features and instructions of 32-bit microcontroller, which is ARM Cortex M3. Next, in Module 4, we will be discussing on the introduction to ARM instruction set. What are the different types of data processing instructions? What are load and store instructions? What are the software interrupt instructions? What do you mean by program status register instructions, loading constants, and ARM v5e extensions, which is a version of ARM, and how do you execute a conditional execution. The outcome of Module 4 is to employ the knowledge of instruction set of ARM processors to develop basic assembly language programs. Coming to Module 5. Module 5 is based on the introduction to thumb instruction set. What is the usage of a thumb register? In ARM, what is thumb interworking? Other types of branch instructions, data processing instructions, stack instructions, and software interrupt instructions. The second part of Module 5 is the efficient C programming, which will tell you about the overview of C compilers and optimization and the basic C data types and what do you mean by C looping structures. The course outcome of Module 5 is to apply the knowledge gained for programming ARM Cortex M3 for different applications. So this is about the complete course content. Now coming to the textbooks which has to be referred for the computer organization and ARM microcontroller. First is Carl Hemacher, which is for computer organization, and second is Andrew N. Sloss, which is for the ARM System Developers Guide, which can be referred for the ARM microcontroller. Thank you so much for watching this video and please watch the upcoming videos also.